This is, as you know, the graduate school of Curtin. It's part of its overall business school. And we've got an excellent turnout here. We were going to split and put some people upstairs, but what we have in terms of our total audience here is we've got all of the people who registered for this RISC Conversation Series event. And that includes not only our own alumni, students and graduates, and people out of the Perth industry community that registered to come along. There's people from the RISC company team here, RISC presenting here tonight in this inaugural event. But we've also got our partners that we share some courses with at Curtin University, and they are online, and welcome to those online on the other side of the world in Scotland. So there's quite a group of people there. And I also believe that we're beaming live into London, to the RISC office there, and also live into Jakarta at the RISC office in that location as well. I'd like to start, before I introduce our special guest and speaker, to first of all offer apologies to Mile Professor Terziowski, who's the Dean of this graduate school. Unfortunately, he's not able to be here this evening because of another commitment. And of course, we always acknowledge the traditional owners to the land, the Whadjuk Noongar people, and their elders past and present. For those of you like me who haven't turned off your mobile phone, could you please do that now? This is an inaugural event. We're very proud of Curtin to be working with RISC on this, what we call the Conversation Series, aimed at providing insight and education to the students and community around matters that we think are important around the general resources and economics industries. RISC is a global oil and gas and resources advisory company. It's the biggest in Australia. It's arguably the biggest in Southeast Asia, and it has branches, as you've heard, in London as well. They have a long and proud history of serving many companies in many areas of M&A, evaluation of assets, right through from economics, geoscience, engineering, and evaluation, risk certifications, and a whole variety of activities that are in that space. Geoff himself, who will be speaking to us tonight, has got this topic of challenges facing the Australian gas industry, real, imagined, or inevitable. And I know that it will be an inspiring and thought-provoking talk, and there will be plenty of opportunity afterwards for questions. And I'd just like to give you some details about Geoff's background. He has 30 years of global experience in the upstream petroleum industry and is the leader of RISC's Unconventional petroleum practice. He's extensive experience in the areas of asset valuation, business strategies, evaluation of conventional and non-conventional petroleum, due diligence for M&A and project finance requirements, and reserves assessment certification in over 50 countries. He's developed a reputation as a keen industry observer and independent thought leader. Geoff is also the past president of the SPE Western Australian section, past member of the SPE International Oil and Gas Reserves Committee for 2007 and 9, co-author of the PRMS application document on coal bed methane, and is a recipient of SPE's 2012 South Asian Pacific Award for Projects, Facilities and Construction, and is a qualified petroleum's reserve and resource evaluator under ASX listing rules. He holds a BSc in Chemistry, an MSc in Petroleum Engineering, and also a member of the Society of Petroleum Engineers. So please welcome Geoff to the podium to give his talk entitled Challenges Facing the Australian Gas Industry, Real, Imagined or Inevitable.
Thank you very much for that introduction, Peter, and welcome everybody to this inaugural series. Welcome to people in Aberdeen, London, Jakarta, and of course welcome to you all here in Perth. So I'm just going to skip through, Peter's already given us a brief introduction about RISC, so I'll just skip through that very quickly. Really, the objective of the talk today is really to try and inspire some conversation, some critical thinking about the industry that we're working in, or that I'm working in, and an industry that's actually very, very important to Australia, as you'll see. So I'm going to be explaining a little bit about the differences between conventional and unconventional gas, and trying to give you some dimensions around the size of the prize. That is why people are interested in this industry. Some thoughts and facts on industry competitiveness. We'll be getting into some issues around strategic decisions that have been made by oil and gas companies and governments, and the impact that they have had, not always a positive impact. And then we'll finish off with some opportunities and challenges, and I'll try and pose some open questions so we can get some genuine discussion going. So as Peter was saying, we've been around since '94. We've effectively got three businesses. We've got a consulting business of which I work, where we provide technical and commercial advice to the oil and gas sector. We have a business called RISC G&G, which is geoscience and geology. The main focus of that business is exploration. And we've also got RISC A&D, which looks after acquisitions and divestments. So we have a very broad range of capability in our company. So if you look at a typical oil and gas life cycle, along the top of the slide, you'll have exploration and appraisal, development, production, and marketing. And you'll see along one of the axes, the left-hand axis, the disciplines that we keep in-house. We have geoscience, geology, petroleum engineering, facilities, planning, commercial, acquisition and divestments. And we are able to slot into pretty much anywhere in terms of the E&P project life cycle. We operate globally. We have an office in London, Dubai, Jakarta, Brisbane and Perth. Before I sort of start talking about the gas industry in Australia, I thought it would be useful to give people a little bit of background of the sort of gas that we're talking about, because there are different types of petroleum. This is a diagram of the what's called the resource triangle. It's been around and modified for a long time. And you will see that at the apex of that triangle we have what is called conventional reservoirs, conventional petroleum. They are trapped. The trapping of the conventional petroleum is affected by the buoyancy of petroleum in water. It can exist in either a liquid or a gas phase. There's really no special processing or refinement needed to convert it to saleable products, and it's generally confined to structural or stratigraphic traps. And then we move down that triangle And on the left-hand side we have the oil phase. I'm not going to be discussing that today. I'm going to be talking about the gas phase, which is on your right-hand side. So we have tight gas, which forms a boundary between conventional and unconventional. We have basin-centred gas, coal bed methane and shale gas. And they all have similarities in that they're not affected by buoyancy rules. The hydrocarbons can be adsorbed into an organic matrix. It can exist in a solid gas or a liquid phase. It almost inevitably requires some form of stimulation to flow, for example, fracture stimulation or heating. And it may require special processing or refinement. And it's generally pervasive over very large areas. So this cartoon shows depositionally how these various types of petroleum accumulations are trapped. And the conventional accumulations you will see are contained in structural traps. They're usually associated with water. They sit on top of a water leg. You have in the centre of the diagram at the top, you have coal seam gas, which is an unconventional, laterally extensive, but generally pretty shallow accumulation. And then deeper down in the basin centre, we have what's called the continuous accumulations, which are shale gas and basin-centred gas that generally exist over many tens of kilometres in terms of area. So very briefly, what is shale gas? Well, commercial shale gas is found in organic rich fine grained sediments that are typically over 20 metres thick, generally very widespread, very high organic content, typically 1 to 20%. They are the source rocks which oil and gas accumulations are formed from. They have a low porosity, typically 2 to 8% of their volume is actually void space. They have ultra low permeability, 500 nanodarcies, which is 500 by 10 to the minus 9 of a darcy. It's very, very small permeability. They need a low clay content, typically less than 30%, because the way you get these rocks to flow is either exploiting any natural fracturing that might be in them or enhancing them using hydraulic fracturing. So the gas is generated from organic material in the rock. The free gas is contained in the pore space of the rock, but you also have gas adsorbed in the organic material, and inevitably they require hydraulic fracture stimulation to flow in commercial quantities. Coming now to tight gas and basin-centred gas. A tight gas is generally contained in a conventional trap. It has a low permeability. The US definition is something like 0.1 millidarcies, so that's about 4 or 5 orders of magnitude greater than a typical shale gas. The reservoirs are typically discontinuous, but they also require hydraulic fracture stimulation to flow in commercial quantities. The basin-centred gas is a very interesting beast. We have a lot of tight gas and basin-centred gas in Australia. The trapping may be stratigraphic or capillary dominated, that is, it gets bound by capillary forces, very low permeability in the order of the shale gas permeability or maybe slightly higher. Basin-centred gas systems are almost always overpressured. That is, they contain gas at a pressure which is significantly higher than you would expect from a normal hydrostatic gradient. They have no down-dip water leg associated with them, and they typically have continuous gas saturations over very long intervals, and we're talking maybe 1,000 metres or more is not unusual. So you can have 1,000 metres of a continuous gas saturation. And also it requires hydraulic fracture stimulation to flow in commercial quantities. Coal seam gas is a very different beast again, and we also have a lot of this in Australia and the east coast of Australia. This gas is contained in coal seams. The gas is actually adsorbed onto the coal surface, It's typically very shallow, in the order of 200 to 1,000 metres, although sometimes can be deeper than that. The coals are usually filled with water. Any pore or fracture space is filled with water. And the permeability is provided through the naturally occurring cleats or fractures in the coal. And you have to dewater the coal to enable the gas to be desorbed and produced by wells. So effectively what happens is that the first initial production period of a coal seam gas well is actually removing water from the coal. Very common phenomena for those people who have been involved with coal mining. The same thing happens with coal seam gas. That enables you to lower the pressure in the coal, and the gas then desorbs from the coal matrix and moves towards the wells. In Australia, most coal seam gas wells do not require fracture stimulation. There's generally enough natural fractures to have adequate permeability. They may require other forms of stimulation, usually some form of hole enlargement or horizontal wells to increase the contact area with the well. But not too many of them need fracture stimulation. So what is the inventory of conventional and unconventional discovered resources in Australia? Here I'm using the convention of trillion standard cubic feet. In the oil and gas industry, we use really weird units. They're a mixture of metrical, imperial, and oil field units of their own. Where I use them, I will try to explain them so you know what it means. A trillion standard cubic feet is 1 billion. There's a mistake on that slide. Who didn't pick that up? 10 to the 12 standard cubic feet, not 10 to the 9. And therefore it's 28 million standard cubic metres. We have a lot of discovered gas in Australia. We've got 172 trillion standard cubic feet of conventional gas and 76 trillion standard cubic feet of unconventional, most of which is coal seam gas on the eastern seaboard. So the gas reserves and resources are scattered around the eastern and western seaboards of Australia, and also in the centre around the Cooper Basin, which is a very mature oil and gas producing province. Because Australia is such a large and very sparsely populated place, we have separate markets for the gas on the East Coast, the West Coast and Northern Territory. The conventions that we're using here that you might see throughout this presentation is 2P, where I mean approved plus probable reserve, which is really a best estimate of what's commercially recoverable, and a 2C, which is a best estimate of the currently non-commercial discovered resources. So these numbers here that I'm giving you are the sum of those two commercial and non-commercial quantities, presently non-commercial quantities. In the unconventional space, we really only have prospective resources. We do have a small quantity of shale gas and tight gases and basin-centred gas, which has been determined to be a contingent resource or a reserve, but it's mainly prospective, that is yet to be discovered. It's inferred from the rocks, and there may even be tests which demonstrate that there's gas there. But it's just potentially recoverable at this stage. It's predominantly tight gas, shale gas and basin-centred gas. It's got huge potential, 400 TCF. It's more than almost twice the amount of discovered plus commercial plus uncommercial resources that exist in Australia today. The other thing that's interesting is that some of it is in very, very remote places in the centre of the country, which is going to create significant challenges for commercialisation. Those basins that have an advantage are basins such as the Perth Basin, which is in the west of the country, the Bowen and Surat basins, which are in the east, and the Cooper Basin, which is in the centre of the country, where they're very close to existing production infrastructure, so they're the areas that are going to be commercialised first. It's very important to understand if your gas has liquids associated with it. And approximately 40% of this inventory of 400 odd TCF of gas is considered to be liquids rich, which is certainly going to assist the commercialisation of it. And again, areas of the Perth Basin stand out, also the Canning and MacArthur Basins in Northern Territory also stand out as being potentially liquids rich. Unfortunately, in the centre of the country, in and around the Cooper Basin, it appears the gas is very, very dry. And that makes commercialisation a bit more challenging. Now, just a couple of words on politics. Developing unconventional resources is actually quite fraught. It's fraught for a number of reasons. It's challenging because it requires a significant amount of capital and time. Some of the projects themselves occupy they have a significant footprint. That is, they occupy a large amount of land or space, and often there's competing use for that land. We have issues in Victoria and Tasmania, which for the present time are effectively closed for business. Those two states have bans on the testing of unconventional gas. New South Wales is also problematic because there's really no bipartisan support, even though there are substantial unconventional resources in New South Wales. In the absence of that bipartisan support, it's going to be difficult for investors to make the sort of investments that's required without some sort of surety of tenure. Western Australia, Northern Territory and Queensland and the South Australian governments are very supportive. However, also in Western Australia, what we're finding is that traditional owner and regulatory approval issues cause significant delays and overheads. And I think Perth Basin and Canning Basin, anybody who's worked in the Perth and Canning Basin will attest to that. So these things take time and patience. I'm not for a moment forming a judgment on whether those issues in relation to traditional owner and regulatory matters are warranted or not. In many cases they are. But the fact is that they're there and they've got to be dealt with, and it's just part of the business environment that you have to work in. This unconventional gas is not theoretical. It's been seen. And you can see here some demonstrations of that around the country. Northern Territory, Edgelabria 2, which tested some of the oldest rocks on the planet. Moving around to the west, Yallaroo 2. And we're fortunate enough to have Steve Broom in the audience here, who's done a lot of work in that area. So if anybody's got some curly questions on fracs, I'm sure Steve will be more than happy to answer them. In the Perth Basin, we've had some very good success with small company like Norwest, which has tested a number of zones. In the centre, we've had Moomba 191 and a number of other wells that have been producing basin-centred gas, and also some tight gas has been tested in Victoria. So it's there. It's not theoretical. There's no question about it. The real issue is, can it be produced commercially? I'm going to change tack a little bit now and move on to Australia's liquefied natural gas industry, which is a very, very important industry for this country. We have 4 projects that are currently operating. We have 2 in Western Australia, we have 1 in the Northern Territory, and we have 1 in Queensland. And they have installed capacity of about 30 million tonnes per annum. There's a further 6 projects which are under construction. We have another 2 in the Carnarvon Basin in Western Australia, 2 in the Browse Basin, another 2 in Eastern Australia. The total amount of investment that's been put into these projects, 8 of those projects since 2007, is $220 billion. 2 of those projects were installed before 2007, that is the North West Shelf project and also the Bayu-Undan Darwin LNG project. It's forecast that by 2019, total production will be 85 million tonnes per annum. That's a lot of gas. Put it in context, in 2014 the amount of revenue that was generated from Australian gas production, according to the Australian Bureau of Statistics, was 18.9 billion Australian dollars, and over 60% of that was from LNG. So it's a very important export earner for the country. Gas production is forecast to more than double by 2019, and the committed projects, as I've said, will bring total exports to 85 million tonnes per annum. Australia will be the largest LNG exporter in the world. How long that will last is anybody's guess. Could be overtaken by the US, but it's a pretty impressive statistic. So in a period of less than a decade, the industry has been transformed. Our gas production will be effectively tripled in that period, and we will have invested over $200 billion, which is real money that's not to be sneezed at. Because LNG pricing from Australia is oil-linked, as is some domestic gas pricing, the revenue that gets generated will really depend on what your oil price assumption is. We've estimated that assuming a $70 a barrel oil price, that gives you approximately $12 per million BTU gas price, that gross revenue will increase to approximately 50 billion, just under $50 billion Australian dollars per annum, and it will place LNG as the second highest value Australian export behind iron ore. So it's a very important earner for the country. Moving on now to industry competitiveness, which is really an important theme of this talk. Firstly, in terms of gas pricing, as I've said, gas pricing in the region is typically traditionally oil-linked. LNG pricing has been anyway. In Australia, gas is predominantly sold on a contract basis, and there's a trend towards oil price linking for this also. And you'll see in this particular diagram in yellow is what's happened to the Australian domestic gas price over the past year with the drop in oil price, and also the movement, basically the drop in oil price. You can see that it's moved from $6 to $10 per million US dollars per million BTU to around $4 to $6 per million BTU. It's effectively as a result of the oil price almost halving. In the region, you see that that gas price competes pretty well with countries like Indonesia and China. And indeed, at the top of the figure, you will see the LNG spot and contract prices, which attract the highest price at all. It's these LNG contract prices is what effectively Australian LNG is being sold at. Also in the figure we show the US Henry Hub, which is the bottom line in the chart. That Henry Hub price is much lower than anything in the region. And there's a number of reasons for that. First and foremost, because gas is produced very, very efficiently in the United States. And this brings me on to my next theme. This actually creates a threat to Australian LNG markets. Australian LNG has to compete internationally. It's an international market, and we sell most of our product to Asia, North Asia. Some of it goes into the global LNG trade, but we're competing with gas from Africa, from the Middle East, from the US, and potentially gas from Canada as well. Although Australia's got an advantage in terms of being closer to those markets, hence the shipping costs are lower, the cost of development can be higher. And this is where the US has an advantage in that delivered price to Asia can be very competitive when Henry Hub prices are low. And what you see in the bar chart there is a range of delivered prices. It's effectively a discounted present value of cost turned into million per million BTU, which is generally the unit that LNG is sold in. It shows how various projects around Australia compete, typically $10 to $12, compared to, say, for example, on the right-hand side of the slide, where you see the US projects at a low Henry Hub price of around $3. They're very competitive. So delivered price into Japan would be something under $10. And if Henry Hub price doubles to $6, then the delivered price would increase to over 12, almost 13. So you can see immediately that the US is a very, very important source of competition for Australian LNG. Just going back. So the point here is that Australia used to have a competitive advantage. 5 years ago, 10 years ago, we had a competitive advantage. Today, that competitive advantage has gone away. In fact, there's really no compelling reason in a number of instances to choose Australian LNG over a number of other sources of that commodity. Another issue with Australia's competitive advantage is costs. Australia has a reputation as a very high-cost country for oil and gas projects, but our analysis shows that globally, large oil and gas projects have got a history of very poor management. That's a story for another day. But the perception of Australia as a high-cost destination, excuse me, is only partially true. For example, a 20% rise in Australian labour costs will only produce a 5% impact on total project costs. There are also a number of underlying strategic decisions that have been made by companies and governments that have a much more material impact. In this particular diagram that you see here, what we show is a range of LNG projects from Australia and around the world, and they've basically all suffered the same fate, with the exception of one, which happens to be an Australian project, where the average forecast overrun is 39%. So this is an industry endemic issue. It's not a specifically Australian issue. Put it to you another way, if you're going to spend $200 billion in one place over a period of less than 10 years, there's going to be an impact. And this is the sort of impact that you're going to see. Which brings me to the next section, where I'm going to be talking about strategic decisions and their impact. So I'm going to be posing some questions here, hopefully to try and get some discussion going at the end of this session. So the number one strategic decision that these companies have made is proliferation versus cooperation. So do you cooperate with other projects, or do you go it alone? That's effectively the strategic decision that you make. Those decisions have been made in terms of proliferation. So all of the projects that have been constructed in Australia to date, and largely around the world, there are some exceptions in the Middle East and in Africa, where government intervention has virtually dictated that there will be cooperation. All of them have chosen the proliferation option. The total capital cost that's been spent since 2007 is $220 billion. So why have these companies or investors, why have they chosen this strategic decision? And what is the cost benefit? I'll just show you some examples of the sorts of decisions that have been made. So excuse me while I just go. This is an example of what's happening in the Carnarvon Basin in Western Australia, where you have potentially four projects, five projects actually, which are effectively operating independently. You have the North West Shelf Joint Venture Project, which started off over 20 years ago now, and was on its own for quite some time, that built its infrastructure. Since then, Pluto came on stream, built its own infrastructure. We have Gorgon and Wheatstone that are building their own infrastructure. Potentially, Scarborough could be an FLNG project. It's so remote. That's probably a logical thing to do. But what you can see there is Spaghetti Junction, and all of these projects are going to their own infrastructure. Why should that be the case? Same thing happening on the east coast, where it's perhaps even less excuse for it, because all of these projects are being constructed at exactly the same time. So effectively you have three projects, QCLNG, APLNG and GLNG, that are all building separate facilities on the same island. And that's what it looks like. So this is Curtis Island. This is the plot plan of each of those facilities. They're right next to each other. Well, so what, you might say? I'll just skip through these in the interest of time. There are other examples in this presentation that you can peruse at your leisure. So what, you might say? Well, what if we ask the question, what if the projects in the Carnarvon Basin and Gladstone used the common LNG facilities? That is, they built all of their facilities with some big picture in mind, and they put their gas into this facility, and then their boat drove up and picked up the LNG and took it to their market. We estimate the total cost for those two projects, current costs, are in the order of $184 billion using the current proliferation strategy. There's potential savings of over $18 billion if a cooperation strategy was pursued. We believe that that's conservative because that excludes any potential synergies in field development and upstream infrastructure, which are considerable. And you can see the areas where the savings could be achieved. LNG trains, basically using, there are tremendous savings to be made by the choice of the site that you choose to put your LNG facility, and also the synergies associated with one constant construction stream rather than having multiple projects competing for the same construction resources. Utility and support systems, storage tanks, marine is a big one. That's jetties, dredging and the marine offloading facilities. Effectively you have to build a port for these things in order to get your gear in and out. There's also site clearance costs and construction camps which have a significant impact. So that's over $18 billion. That's effectively one of these projects. That's a lot of money. So let's look at the impact of these strategic decisions. So globally, what we've seen on our estimates, total aggregate cost overruns since 2007 in global LNG projects, that's not just in Australia, that's around the world, have been $70 billion. In 2013, Woodside abandoned the James Price Point onshore operation in favour of LNG. Why? Because it was a high cost environment and the James Price Point option wouldn't stack up. In 2014, so at the same time as that, you have other projects such as in the same area, such as the Ichthys project and Shell's Prelude project, which are under construction. So there are synergies there that just weren't taken advantage of. The implication of that particular decision to abandon James Price Point not only caused the state government considerable embarrassment because there was a lot of political capital invested in it, but it also removed an opportunity for the traditional owners of the land in and around James Price Point to get some benefit. So the lack of cooperation, I think, has had an impact, a direct impact on those people. In 2014, we saw oil prices fall from $100 to $60. So what happened in 2015? We have BG, British Gas, write down $6.8 billion in their East Coast project. Arrow, which is a Shell PetroChina joint venture, they announced the cancellation of their project. So stuff is not happening because the costs are too high. And the costs are too high because of the lack of cooperation. The reserve base, if you look at the reserve base of these East Coast projects, and again we need to question some of the decision making around these projects, What this diagram shows is that 2P reserves, that is the most likely reserves that you expect to recover, for all of the projects, they're short of 2P reserves to secure 20 years of supply. Now, most LNG projects are written in terms of 10 to 15 year type contracts, but you really make your money when you extend these facilities out for a longer period of time. You look at the rate of return, for example, between a 15-year a project that's operating at 15 years at capacity compared to 20 years at capacity, it's a very big difference, big impact. So they don't have 20 years of supply. Now, some of those projects will be able to grow their reserves, so this is just a snapshot in time. But GLNG in particular is going to be reliant on third-party supply, so effectively they're going to become a tolling operation. So the question is, how were decisions made in respect of the project size versus its reserve space? So coming into the last few minutes now, opportunities and challenges. So the challenge is, how do we commercialise Australia's vast potential? The first challenge is probably for the onshore part of it, is around well costs. In an unconventional project, well costs may be up to 90% of total costs. And for a comparable scope, Australian well costs are typically higher than they are in other regions. And the reasons for that could be ageing equipment, limited competition, inefficient services, regulation and lower activity levels also provide a reason. We do have higher labour costs, we do have remote operations and lack of infrastructure, and there's not a great deal you can do about that. However, those higher costs directly affect profitability. And what you will see in the bottom chart is the impact of a typical unconventional well if you can save 15 to 20% of the cost, and if you can save something around just over 50% of the cost, using some sort of stretch target potential. Using a business as usual approach, that is, if you do enough of these operations, you'll slowly get better at them, you would expect those well cost savings to have an impact on your bottom line of about 75 cents per gigajoule, which is about per 1,000 standard cubic feet, nominal after tax. If you could really achieve your stretch target, and these are the sorts of stretch targets that have been achieved regularly in the US, where you get over 50% cost reduction, the potential to increase that saving is over $3, which is a huge impact in terms of your profitability and the ability to be able to get that gas to the market. So a well cost reduction target of 50% is not only feasible, but it's necessary to monetise the substantial potential that exists. And again, this is where cooperation between companies that have unconventional acreage could actually help achieve a number of these savings. So the challenge that I'm setting now, Australia has vast natural resources. The challenge is, how can we make the industry more competitive? How can we improve cooperation amongst projects to get the best result for all? Why is Australian iron ore amongst the lowest cost in the world, but our petroleum is believed to be amongst the most expensive? How do we get to that situation? And what role should governments, management and shareholders play in these strategic decisions that get made? Final thoughts. Despite rumours to the contrary, the oil and gas industry is not dead. There are great opportunities for innovative thinkers. Data and knowledge management, I think, is embryonic. We just don't know where that's going to take us. Automation has barely begun. Decision making, in my view, is clearly remedial and needs to be improved. And there are plenty of opportunities around making the case for sound environmental and sustainable practices, because it's really our world. Finish off with a couple of thoughts that tell you that really what you think is impossible may not necessarily be impossible. So Lord Kelvin in 1895, that famous mathematician and physicist, said that heavier than air flying machines were impossible. You've all heard of the famous quote from the chairman of IBM, Well, I think there's a world market for about 5 computers. That's probably one of the best. And the final quote comes from somebody who is pretty close to me. The oil and gas industry has no future. That was a conversation I was having with my best friend in 1972 in year 12 when discussing career options. Thank you very much.
Well, I think after that talk we can all be glad that that last piece of advice wasn't taken by Geoff. So thank you, Geoff, for a great talk. What we want to do now is to move on to question times. And just for those of you I didn't introduce myself to and don't know, I'm Peter Moore. I'm the chair of the Graduate School Advisory Board here, amongst a few other things, and a bit of oil and gas background. We have questions from this audience in here. If there's anything that comes through on the live chat streaming, then I think Lisa will let us know. And Katrina has the microphone for questions as they can be asked. So maybe if I can just open up to the audience for some questions.
Question there, Peter.
Perhaps more than a question, it's a comment. I come from an operating environment, I work for an operating company, and the need for cost improvement is still there. It's not only during the capital project development, it's during operations. Nowadays, there is no other way for operators to go than cooperate to optimize cost and reduce cost to be able to operate in this low price environment. So I'm very glad that the topic is up there. And the key question is, how can we make it happen? Because at least for my company, I think the appetite is there. We are just trying to understand the environment to make it happen. Who do we need to talk to? The government, the other companies, the universities. Who is the driver for this effort? We need to share cost.
Well, I mean, that's a really interesting observation. Of course, the ability to cooperate in an operating mode is very important. To some extent, it's easier because you've already made your investment, you've built your project, it just makes sense for everyone. How you actually get that happening, it takes leadership, I think, ultimately. However, the real impact of the lack of cooperation, or put it positively, the impact of cooperation occurs a long way before then. It occurs when you're getting to the point of actually thinking about how you're going to do this project. What role do governments play in making sure that the investment that gets in infrastructure that gets made is the best possible investment for the industry and for the country, without necessarily suggesting that they have a command and control type economy. If you look at what the Western Australian government was trying to do in Northern Australia with James Price Point, that was very noble, but it was too little, too late. That concept should have happened 10 years before, because you had these big fields, the big Browse fields, the Ichthys project, the Browse LNG project, Prelude. They were all there. They'd been discovered 10 years before, and I'm afraid somebody in government somewhere on the line was asleep at the wheel, because that great idea just came too late. We'd have a very different type of project structure there than we do now. If you look at, for example, what happens in the Middle East, you go to Qatar, you get given your 20 square miles by 20 square miles of the North Field. There you go, that's yours. If you need some more, we'll give you some more. You produce the gas. It goes into a common LNG or an LNG facility that you might construct, which is in an LNG park, where all of the utilities and everything there is provided. All you have to do is put your kit there, put your gas in there, drive your boat up and sell it. Lowest cost LNG in the world because of that factory type approach. In East Africa, for Mozambique, the government has basically insisted that the LNG facilities be in one place, and there's a certain number of trains that will be constructed in an orderly fashion. There's a lot of other issues associated with whether those projects and when those projects are going to go ahead, but that isn't one of them. So they've made some good choices there.
They're still allowing FLNG as well.
Beg your pardon?
They're still allowing FLNG at Mozambique as well.
You look at, there are opportunities in Northern Australia still. There are opportunities in maybe not so much in the Browse. A lot of the opportunities have been lost, but certainly in Northern Australia, I think that there are still opportunities for cooperation.
James Price point, unfortunately as well, the onshore guys have lost an evacuation route for their gas as well, haven't they? So the Peru's, and they have no means of getting gas out of the Kine Basin either.
I don't
Not
believe.
only the offshore guys coming onshore, it's the onshore guys trying to export gas out.
I don't think that that's necessarily a barrier. It would have been cheaper if there had been a James Price Point facility. You wouldn't have had so far to send your gas. But now you've got to build a pipeline to Dampier, which is a bit further. Yeah, so it is an additional cost, but I don't think it's necessarily a showstopper in terms of export, for the export option there. But yeah, you're right. It will cost more than it otherwise should have cost.
Would you better comment on whether our current tax regime is appropriate, sort of strike rate risk, political risk, all those sort of things, compared to other countries looking to develop?
Yeah, look, yeah.
Sorry, could you repeat the question back?
Okay.
Could you use the microphone because London can't hear what is being said.
So my question was, would you think that our current taxation regime would be appropriate for the level of risk, strike rate, those sort of things, political risk in a country compared to other countries looking to develop oil and gas?
I'm going to answer that in two parts. The PRRT regime is a very healthy and favourable regime for oil and gas explorers and producers. It's an efficient tax because it's a tax you pay when you make a profit. You don't pay a tax before you've made a profit. So it works very well, and it certainly has not been a barrier to investment in this country. The sorts of taxes that are inefficient are things like state royalties, which you pay up front, and that has a significant impost. I think Australia isn't the most competitive tax regime in the world, but it's by a long stretch not the worst. There are a lot more punitive regimes out there. So I don't necessarily think that taxation per se is the issue here.
Thank you. I'd like to just pose a question. In terms of projects like Gorgon, Wheatstone and probably Pluto before that, seeing as the vast bulk of the really heavy steel works built overseas, Samsung yards in Korea and others, they bring it to us and we simply assemble it. So I'm asking a question, if the primary parts of the product are built in some of the most labour efficient countries in the world, why is it that something like Gorgon overruns its project cost by 50%? And so just as a second one, if you'd like to or not, comment on Woodside's twice now deferral of FID on Browse and the fact that it's only about 700 nautical miles to pipe the gas back to the North West Shelf. Thanks.
Yeah, look, there are a number of reasons why the Gorgon project has overrun. Perhaps I'll pass that question over to my colleague, who I'm going to put in the spot over there, Martin Wilkes, who's probably ducking and weaving as fast as he can go. And what was the other question? The other question was...
Just a comment. excuse me, a comment on Woodside's twice deferral of FID.
Yeah, the problem with piping the gas to the Northwest Shelf is that it's got to hit the beach very hard. Otherwise, you just don't get the rate of return that you need. And it's also a deferral issue. Those trains in the Northwest Shelf are going to be starting to come off plateau unless they find more gas or another source of gas. They're going to be coming off plateau in around the early 2020s. And it's going to take a few years to free up enough capacity to make it worthwhile to build a pipeline and bring it to the Northwest Shelf. So, I think that's been looked at very extensively, and it really comes down to a rate of return issue. Martin, do you want to answer the question on Gorgon?
One from RISC as well. We've been in the press quite a lot about Gorgon actually, and I think the last one was we were actually quoted by the International Trade Union and Transport Workers Union, and I'm not normally one to agree with the unions on this, but they commissioned a study by Sydney University which indicated that actually a lot of the work that's going on with Gorgon is high quality and first class. And that is, yes, there are issues about labour productivity and costs, but the productivity to a large extent is caused by the location and the fact that you're in a Class A nature reserve, you're having to bubble wrap it and wash everything twice or 3 times, and there's a lot of double and even triple handling. And I would actually recommend that report by, I think, Sydney University to anyone who wants to have a read. It's got quite a lot of information in that. Our view has always been that actually the real issue, and it comes back to what Geoff was mentioning earlier in his discussion, is the original decision. Gorgon joint venture decided to go to Barrow back in 2000, 2001. They had to make an Act of Parliament get changed in 2003, and from then on, that decision was never really questioned. They were locked into a corner. And even recently, the Gorgon management has said they completely underestimated the impact of working on Barrow Island. And in our view, definitely the core rationale behind the Gorgon overrun is the Barrow Island factor.
Just location, yeah. Thanks, Martin.
Yeah, Geoff, you've talked about how the US can do things very well and how they can learn and cut costs. I guess that with the CSG developments on the East Coast, we've had quite a lot of experience now in drilling wells and getting productivity up to these projects on Curtis Island. How well is Australia learning and demonstrated the sort of cost-cutting capability that the Americans have done for many a year?
Well, I think they've made progress, Peter, but I don't think they've made the progress that they could have made. The times and costs have come down substantially from where they were, but I think there was an over-specification to start with. I think there are regulatory issues which don't exist in the US that have a significant impact on costs. And I also think that the specification of the wells, that is the standards to which you drill these wells, are probably significantly over-specified. The mining industry has been drilling coal bed methane wells for 100 years, right? And they can do it for a fraction of the cost. As soon as you put petroleum in front of it, all of a sudden it becomes gold-plated. Is all of that gold plating warranted? I don't think so.
Geoff, what sort of skills do you think are needed to take advantage of the tremendous potential that we have in terms of the gas industry? And do we have those skills available in Australia to really take advantage?
Well, it's interesting, if you look at who the entrepreneurs are that are making the unconventional industry go, they started off being very small companies. Companies in the eastern states, companies like Ocker, like QGC, before it got taken out by BG, companies like Arrow, these small companies, Santos and Origin did a pretty good job in the eastern states. They got on the bandwagon, they saw which way it was going and they got on the bandwagon early. But in terms of the initial entrepreneurialism, that was always done by small companies. West Coast is the same, Central Australia is the same. You've got the Central Petroleums, you've got the Norwests, you've got the Burus, AWE. It's not a small company, but it's small by international standards. You've got Transurf trying to do things. These are companies that are investing risk capital in the hope of striking it lucky. So they have a significant role to play. So first and foremost, I think it's the ability to be able to attract capital for those small companies, and that means you have to have a pretty good team. You have to have a pretty good experienced team, and that team may not always be in this country. You may have to bring them in order to satisfy investors that you've got the wherewithal to be able to make that investment. The next stage, I think, is when you're looking to commercialise, and because of the amount of money that's involved, you're talking a typical unconventional play in Australia would cost $200 million to commercialise. And you have to spend $200 million before you know whether you've got anything that's potentially commercial. That's not developing it, that's drilling wells, testing them, pilot testing, etc., etc. A couple of $100 million. And you might have to throw that money away at the end. So you need long arms and deep pockets for that sort of thing. So again, you're looking for a different type of investor, and this is where the larger companies have got a significant role to play. Skill sets, I would say that the skill sets, the technical skill sets that you need, first and foremost, are an open mind. Just because something's worked somewhere else, don't assume that it's going to work here or in a different environment. That's the biggest mistake that everybody makes. If you look at the success that's happened on the East Coast, that success has happened after maybe a decade of trying what was effectively North American technology by North American engineers. There's nothing wrong with North American engineers. They're very good. But they tried to say this is the way we did it there. The stress regimes are completely different. The rocks are completely different. It just didn't work. So it took somebody to just try something different and think about it in a different way. So innovation, I think, is the most important thing in that regard. Also, the ability to be able to work effectively in a team and integrate all of the information. So a lot of these skills are sort of non-technical skills as well.
Thank you, Geoff. I'm just going to take the opportunity to wrap it up there. I can see there's quite a few remaining questions, but we are going to have a bit of a gathering together, and I know that some people have to leave. So what I'd like to do now is just thank you, Geoff, for the talk that you've given. I think many of us here who are involved in the industry have an insight of what's gone on, but it's the wisdom that comes from RISC and people like Geoff to be able to put that into context and explain the significance of it and some of the implications of it. I have a dozen questions I'd like to ask myself and pick his brains, but maybe over some coffee. I think what I would like to do also is that I'd like to thank the people who've actually put on this event. I'm just here doing a little bit of emceeing, but a lot of effort went into creating the RISC Conversation Series, which will continue over quite a period of time. And I'd like to thank RISC for working with us to do that, and the team from RISC in helping put that together, and also our own team from Curtin. Lisa in particular was involved in getting this series up and running, the events team, the external affairs group, the group here at the Curtin Graduate School of Business, and the IT help that we've had during this evening as we do something that's not generally done, which is beaming live to other venues. We have taken some photos tonight. I would ask you, if you don't mind, to sign a form. Universities require signatures for use of photographs if we want to put them into our media spots. So if you could sign that on the way out, that would be excellent. I'd like to thank you all for being a good group of attendees and for asking lots of interesting questions. And we'll break now and continue the conversation in an informal way. So if you could really join me in thanking RISC and Geoff. Thank you, Peter. Thank you.